Chromium 3 can oxidize chromium 2. I'm just reading A, 30A. It would oxidize, so the statement is chromium 3 can oxidize chromium 2, but not chromium metal. That is choice A. I would like to eliminate choice A. I don't feel like A is correct. And so my question was, what would chromium 3 oxidize chromium 2 to? The answer is chromium 3. Reducing itself to chromium 2, this reaction will not occur. This reaction has an E of 0. You're oxidizing and reducing the same thing. So I think choice A is poor.
So the fact that it's reducing something into itself.
Right, this is not a reaction. I gave it to you last time. I didn't take it back. I don't know. I haven't touched it since I handed it to you. Because this reaction is not spontaneous. The reactants and the products are the same thing. Delta G here is 0. This reaction will not occur. It's not a reaction. You are. But the cell potential for this is 0 is another thing I could say. Like, it's not spontaneous.
So in the same way, could you say that it can't reduce it either?
Chromium 3, no, because chromium 3 won't be further oxidized. Is that a choice?
Chromium 3 reducing chromium 2.
Okay, I see what you're reading. I don't know. I just did A. I eliminated A. I'm showing you how I did this. I can just tell you what the answer is. I hope that it's crossed on my paper. Maybe I'll cheat and find it so I look less dumb. I hope I'm on like B, everyone. So then I tried B. It says chromium 3 can oxidize chromium, metal, but chromium 3 cannot oxidize chromium 2. So I like that statement because, again, if you wanted me to use reduction potentials, the reduction potential, or the cell potential for this would be 0. So I agree that this reaction is not going to happen. I don't have to do any math to get that cell potential, but it's saying that this reaction can happen. Okay, so chromium 3 can oxidize chromium. Well, we have two things that we can oxidize chromium into. So what I'm feeling like is maybe we could do this. That seemed like a good product. So the chromium 3 is oxidizing the chromium. It itself is being reduced. So I'd kind of like to know what the cell potential is for this. And so I think it's going to be given to me. I know that chromium 3 going to chromium 2 has a reduction potential of minus 0.407. And chromium going to chromium 2 has a reduction potential of minus 0.914. But this would be oxidized, so it would be E reduction at the cathode minus E reduction at the anode. This number is going to be greater than 0. This is true. This is going to happen. Good. B is a good answer. I like the blank stares.
Because it's
Yes, so like I'm looking for something that is spontaneous. So when you say it can oxidize it or can reduce it, my expectation is that E is going to be positive. If it can happen. My expectation is that E is going to be negative or 0 if I say it can't happen. So my argument for E being 0 was these times when I'm reacting something but creating, like, it's not a reaction. And so when I got this positive number, I'm sure I quit because I was, going for time here. But let's look at C and D and see if this keeps making sense. So this says chromium 3 can oxidize both chromium and chromium. And I don't agree with that first step. It's the same one that I keep not agreeing with. Pretty hell-bent on not thinking that's the right answer. It's been in 3 of these, so let's go. The last one, chromium 3 can oxidize chromium. Good with that. And reduce chromium 2, this is what Brecken was speaking of. Chromium 3 can reduce chromium 2, so that means I need to get chromium over here as a metal. If I'm going to reduce the chromium 2, it's going to go down to its metallic state. But over here I would need a more positive chromium, which I don't have any reduction potentials for, so I didn't find that to be a compelling answer either. We weren't given any information about chromium 6, so I threw that away. Do you guys eliminate all of the answers, or when you get something good, do you stop? Or how did you approach this? I don't know, I thought this was a harder one.
It was more like, I looked like you can't reduce into yourself. Like, because that one's like, that's like getting it back into itself.
Right.
It's like this.
The one that has the 0 for the E confused me, and I knew the other ones would work, like the 3 plus and the regular chromium. I was like, that one will work, so I'll take the 50-50, and then I'm lost.
Okay, so those was 19 and 30. Are there any others you had trouble with? I got 37. That was the one where I reread it. I'm like, yeah, I got that wrong. That's the one about hypothesis versus theory. I sucked at that one, but I read it again. I got it right. I wrote Michael Walker a note like, oops, read this one again. Definitely the wrong answer.
29, I'm not sure how to balance the electrons.
29, I'm not sure how to balance the electrons.
I just forgot to balance the electrons. Yeah, me too. I was like, all the elements have been on. Yeah. But I was not done.
Okay, so lead is going to lead 2 plus. So how many electrons is lead losing?
2.
Nitrate is going to nitric oxide. In nitric oxide, nitrogen has an oxidation state of +2 because oxygen is -2. What is it in nitrate? What is the oxidation number of nitrogen in nitrate? +5. So this is a 3 electron gain. So I have 2 strategies here. One is to do the shortcut I said I'd never do. They've kind of inspired me to do it. The other is to do it the right way and just to freaking start writing. Lead goes to lead 2 plus 2 electrons. Nitrate plus 3 electrons goes to nitric oxide. The top one is balanced, the bottom one is not. I need 3 oxygens on this side to balance with 3 oxygens on this side, so I add 2 waters. I need 4 hydrogens to balance with 4 hydrogens, so I add 4 H pluses. I check the charge, 4 pluses and 4 minuses is 0. This side is also 0. So these are the 2 half equations. I need to combine these using the lowest common multiple of 2 and 3. And so I'm going to have 3 leads. I'm going to have 2 nitrates. I'm going to have 8 H pluses. And over here, I'm going to have 3 nitric oxides, 2 leads, and 4 waters. 2, 3. Okay, I multiplied better. Does that make sense?
Yeah.
Is that how you did it, or you tried to do it in your head?
No, I just looked at it and I just like kind of found the hydrogen.
So if you want to do it in your head, as soon as you get the 2 and the 3, you write down the 3 and the 2.
Well, I didn't think of splitting it into 2.
So I'm saying, even if you don't want to write this part, you always know that you're going to split it into 2 in terms of one thing is being oxidized, one thing is being reduced, and the electrons have to balance, which is the part you were saying didn't make sense to you.
I didn't even think about oxidation.
Okay, well, I can't help you then. You know that you're in topic 9, right?
Yeah, because of the like.
I don't even know what the question was. The coefficient of H plus was 8, which is D. Anything else on paper 1 that you'd like to talk about? 23. I have a lot of emotions about this. I don't know if I'm gonna agree with myself anymore. I'm not sure, Brecken. I'm just writing the problem right now. I'll look in a second. Okay, so one of the things that struck me on paper 2, which I understand I haven't handed to you, I was just doing things in terms, is you're asked a question about a catalyst, and a number of you got it right, but I think you shouldn't have. So I'm going to add this to the list of surprises. No, on paper 2, there was a question about adding a dilute versus concentrated catalyst and how that would affect the yields. I think anyone who's been playing along, do you want your paper 2 to look at these 2 questions at the same time? You can't stand it, can you? At least in this class, so I'm gonna pull it to the front, you know, Casey and Nicole. Yes, dear. No. Just a sad little metal.
So then
Germanium? Germanium? So there's a stair step, right?
Yeah.
So the stair step goes between boron and aluminum, aluminum and silicon, silicon and germanium, germanium and arsenic, arsenic and antimony, antimony and tellurium.
Okay.
So aluminum doesn't count, but anything else touches counts.
There was a question about
Yes, the answer is not germanium. Really? Like, I don't know what your expectations are, Audrey, so you can feel
What is this?
Wow. Did anyone not get one?
She's so about it. She's like, how could this happen?
Look at that spicy squid.
Mohab did not get one because he's too shy to tell me. Okay, so I am trying to call your attention to a problem on here. I'm not sure what problem it is, so just give me a second. It's when you add a dilute sulfuric acid catalyst. What is the, it's going to be on page 18.
I hate that there's not many pages. It's so the whole site, I think 29 pages. Like, they said to check and see if any pages are missing. I was flipping through so like when they tell me to check, I was like, I didn't even get through. I was still flipping.
Which one is this
I
one?
don't feel like I'm going to have your attention for a minute. So.
The one with that.
I don't know. She's like, where are these values from? I don't know.
There's too many. Or zero, I guess. What is that?
Okay, so I didn't fail.
Hi.
What question is this on?
It's on question 4A2 that I'm thinking about. And I'm drawing a similarity or contrast to the multiple choice question that Audrey asked about, but I've since lost that question, so I'm trying to find it. So the multiple choice question I want you to think about is number 23.
Where's number 23?
So this question in black is question 23 on the multiple choice. That was Audrey's question. I said I thought that it had some strange analogies to a question on paper 2. The question on paper 2 that I am referring to is 4A2.
What did you do? With the reason? It's zeroth order. With respect to the nuclear file, that's why you can use a product order.
Yeah. Right. Yeah.
So,
It's one of
I
those.
think
With the reason?
It can't be both non-polar and polar.
Yeah,
That is
it's
like,
like, it's non-polar. I just put polar at the last minute.
you can't contradict yourself and get a mark.
Oh.
That's why there's a question mark there.
Yeah, I just got at the last minute. I was like, maybe I'm wrong. But, only one, oh yeah, okay, that was the same.
Yeah, you needed a reason, I'm sorry. Identify and Boris, he erased the word please. Brecken said something nice and no one else acknowledged.
I thought saying responding to like the word something.
Really just trying to make the back page blank, it's just so funny. Yeah, they have to be in a line. Because there's one drop. All of the 4 things are mixed together, so when they split. Yes, math skills right there. Everybody did 20, choose 3, babe, you killed
I
it.
didn't get my grade yet.
I did 20 choose 3.
I did that too. I literally did 20 choose 3.
I was in the back.
I was literally thinking about the exact same thing.
I was still thinking about
I love my question mark on it.
Okay,
Because I had math the previous day.
so,
Okay, can you take your headphones off, because I'm gonna scream at Emma when she comes back. Amarachi, take your headphones off, I can't do it.
oh, it's an air.
That's so good. I love that.
I love this. I averaged all of my answers to a second grade.
Oh, 7
Yeah, 17, I'm sorry.
That's good.
Yes?
I have a question on 17. So, I thought I was right, but I'm wrong. And
Okay.
I would like to know the actual answer.
Someday I'll tell my story. I wrote it on the board in case you want to know the answer. So if you came to first period biology today, you would learn that DNA travels through the pores of agarose gel at different rates depending on its size. That is the only difference between these 2 things. They have the same PI, but they have different sizes. So glycine.
Oh, I read the question wrong. Oh, I thought it would be like, why are they above, like,
Right. If you're gonna fight marks, you know, write another pen. You don't have marks. Yeah, harder work for now.
It's 3, Elizabeth. It's 3. I got 11.01.
That's what I'm trying to tell.
She gave me all.
Are you talking about this one?
That's the right answer.
It can't be this one. There's this one with this.
So,
it can't be
my issue
this
was the
one
extended
because
time
you
people
can't
got
convert
lost and I
back to
gave
the
them
reactant.
to,
It can't be this one because there's no the
so I
equilibrium
didn't
is
have to go through that one.
just like literally it just says synthesizing a target molecule.
No, but you
So
already
I
have
graded hers while y'all looked at
I didn't even pay attention to that. I literally saw synthesizing a target molecule.
I wouldn't have from the target molecule.
That first 3, 4 words is literally all I like.
do it.
EPA equals radiation doesn't have to stop.
Oh, wait. Yeah, no.
Why?
Because of this. I mean,
But I had no idea. This was the first time I ever gotten one of these curves. Sorry, I was so happy. I was so happy.
because of this.
Oh, ew.
So I didn't roll like all of this down.
It was pretty fast to grade for that reason. I'm not saying it was a better test for it, but I felt like there was very little orgo. I felt like there was very little, orgo 11. Which I quite like. Yes, I wish.
Here's the map.
Okay, so here we go. I am back on the multiple choice. I'm looking at number 23. And I wrote down the equilibrium constant. Is everyone okay with how I wrote it? Why did I not include the water? Because it's a liquid. And so I think all of you should have said that. Everything else is aqueous, but the water's a liquid. So why would evaporating the water do anything? Because they're asking me about it here. It makes things more concentrated, and so in a lot of ways, evaporating the water is similar to making the volume of a gas smaller. The volume of this solution is smaller. And so if you were to evaporate the water, which way would this reaction shift? To the right.
Oh, no, to
Sorry. Yeah. Whatever. Let's all point this way and not say right and left. So the water can affect the yield, even though it's not in our equilibrium constant expression. The number of you who seem to know that was shocking to me. When I first answered the dilute versus concentrated sulfuric acid, I said that a catalyst does not shift the position of an equilibrium. I don't think it was at all obvious that I was adding different volumes of them. It didn't say you're adding the same amount of acid. It said Moheb puts in a drop of dilute, Audrey puts in a drop of concentrated. What happens to the yield? But none of you seem to suffer this embarrassing misunderstanding. So we'll talk about some other misunderstandings where I don't understand, how y'all figured it out. So in this particular problem, what would the addition of HCl do? We hope that it would increase the concentration of chloride, but what if the concentration of chloride is already 1 molar and you're adding 0.01 molar? I thought this question was awful.
I think we make a lot of assumptions.
It's unclear as to what it would do, but I took it as it increases it because I feel like that's what they were trying to imply.
That's what we're just trying to see what they probably want, not what actually would be real.
So I'm sure that the addition of concentrated HCl should shift this thing forward. I am not sure when they give me both of those things if I'm supposed to read 0.01 molar different. So here's the question if you're not looking at, this says add 0.01 molar Cl minus. This says add concentrated. They're both HCl before y'all get mad at me. And this says evaporate water. So now that they're drawing this distinction, are you going to change your mind about how you see that first one? So it implies that it's going to be more dilute. Maybe I would in fact be lowering this concentration.
For me, it was in the third one says evaporated water, and so that's what I was like, okay, they're talking about water, so it's going to be the dilute one has more water. Yeah, it's like that. You have to just like use that context.
I think it's a terrible question.
But isn't that like water with HCl, like, right? The 0.01 molar.
Yeah.
So if you add water, you add more water to.
But water doesn't enter into this equation. Like you're treating it like it does, but you all told me it doesn't. So I'm like a little bit confused about how to deal with it. I do have a way of dealing with it. I can talk about how the concentration of all of these things change. The bottom being more affected than the top, and so the reaction shifting to the side with fewer things that way if you evaporate the water.
The problem is that you understand the equation.
Yes, Becky, the answer is C. So adding concentrated Cl minus, we all agree would shift it forward. So we were in a position where we all knew that 2 was correct. So we had to look at 1 and 3. I'm gonna look at 1 and 3 as opposites. I'm gonna decide that this sort of means adding some extra watery stuff, and this means subtracting some watery stuff. And so they can't both be true, and so I've gotta decide which one is the most likely to be true. I did not like this question. The fact that it appeared on both papers made me really uncomfortable. I think we tried very hard to pound into your head that the water does not appear in this concentrate, in this expression, and they found 2 ways to make it appear. I thought that was poopy.
To me, I guess it seemed like more of a common sense thing than a chem thing. It was like, wow, more water. So like when you're thinking about it, 2 chemistry.
Okay, anything else on the multiple choice? Yes, ma'am. 18 on the multiple choice?
Yes.
So I wanted the initial rate, right? I don't know how you got another answer, so you make me super nervous.
I just don't know how to.
Okay, so what I did was I said that the initial rate is gonna be the rate at time 0, so I wanted to find the slope of the line that passed through the first 2 points. So I said that the rate is the rise over the run. So the rise was 1.4 to 1.6, and the run was 0.1, 0.2, 0.2. And so the rate was gonna be equal to, what did I do wrong? I got you. 0 to 2, thank you. And so it was gonna be equal to 0.1. It's obviously negative because it's going down. I didn't care about the sign. So you just wanna take that first data point, find the tangent as close to 0 as you can. Anything else in the multiple choice, or can I put it away and look at the short answer with you? I have a harder question there. Can't wait.
I know exactly. That's what I guess. No, I guess. Like, just the rate of what I got. Because I wasn't.
So Brecken asked me about number 15, where you had to put together these ideas. It says which magnitudes of lattice enthalpy and enthalpy of hydration would result in the most exothermic enthalpy of solution. So I know that the delta H of solution is equal to the delta H of the lattice plus the delta H of hydration. I know that this number is always positive, so I'd like it to be as small as possible. I know that this number is always negative, so I'd like it to be as large as possible. So I chose whichever one was that. Brecken tells me it's C. That was number 15. How did you guys go about it? I had to draw the picture, and then I had to think about the signs I associated with it, because the question was about magnitude. So I had to know lattice enthalpy was always positive and hydration was always negative.
I was like, B, you know. I was like, I knew something had to be small and something had to be large, but I didn't know which one it was. I was just like, anything is like,
31.
So 31, what factors affect the amount of stuff made during electrolysis? The charge matters, but the molar mass won't matter, because that'll determine the mass, but it won't affect the moles. And the duration of electrolysis will matter. So 1 and 3, so I think it's gonna be B.
I remember the equation for
Yeah.
equalization. I was like, I knew time mattered and the charge mattered, and that was
She
all.
used the question on the same question from our later test.
Okay, multiple choice, multiple choice. You just have to draw the molecules, so H2S looks like this. There's no multiple bonds, so it can't have HNO3. On the other hand, looks like this, and so this double bond can be there or there, so it has resonance.
For 12, for 12, it says alloying a metal, or does alloying a metal with a metal of a smaller radius disrupt the lattice and make it more difficult for atoms to slide over? Wouldn't that affect electrical conductivity? Because
Not necessarily, because that valence electron would still be in the delocalized electron state. It's unclear why that would be different, but it will affect the ductility and malleability. It'll make them both worse. It'll be harder for things to roll over each other and stretch because one of them, but the strength will increase because you decrease those other two. Mohab, is that a question or just a, you're holding your hand like this?
Oh no, I just grabbed
It looks like a question.
No, I just grabbed it.
On question 11, which molecule has a tetrahedral molecular geometry? You just need to draw them out. So if I were to draw you the Lewis structures of these four molecules, N is the central atom, it's attached to 3 O's, one of which in turn is attached to an H. This can't be tetrahedral, as it's only attached to 3 things. SF4, has 5 electron domains, so it can't be tetrahedral because it has a lone pair on that central sulfur. Xenon X4 has 2 lone pairs. It has 2 more electrons than sulfur, so those 2 more electrons go on the central atom. So he's going to be square planar, so that leaves me XeO4, and it looks like this. Or you can choose the not formal charge 0, 1. Good choice. You look very unhappy with that. What?
24.
Equal volumes of a 0.1 molar weak acid and strong acid are titrated with sodium hydroxide. What's the same? The answer is going to be the amount of sodium hydroxide to neutralize it, C.
Why?
Because that's how many moles of H plus you got. It's fixed.
But
All
if-
neutralization reactions go to completion. When
But
you
then-
drew your answer in this problem, you showed equivalence at 20, even though you have the world's weakest acid. You have NH4 plus. The half equivalence is 9. It's barely an acid, but the equivalence still happens at 20. The equivalence point always occurs when the moles of acid are equal to the moles of base. It doesn't matter if it's a strong acid or a weak acid.
Wait, so is the equivalence point complete neutralization?
I mean, it's when moles of acid equal moles of base, yes.
You see, I forgot what neutral meant. I forgot neutral is not like.
It does not mean neutral. Which alkane has the lowest standard entropy? So entropy is a measure of disorder. We can change it by changing a solid into a gas. We can change it by making a molecule more complicated. So CH4 is the simplest molecule, so it would have the lowest standard entropy. And then butane is the most complicated molecule, so it would have the highest standard entropy, the most ways it can orient itself in space.
is it like when you're talking about the simplest, this is like the electron is out like what
We're talking really about the number of atoms, like how many different ways could the atoms be positioned in space. There is a mass argument you can make, but I've never made it in IB chemistry, and so I'm eager not to. No, because these things are at the same temperature. So we're saying that at some value of temperature, you could argue that methane, all it can really do is move around. But methane, in addition to being able to move around and stretch, can also bend itself in a whole lot of different ways. 17. At which temperature could delta H, delta S, and delta G all be positive?
Why is it low?
So it's negative.
You got a 7. You got a 7.
And you want it to be all positive. So the temperature negative. No, it's neutral. Because they say all of them.
Okay, so I think Rami just told you the answer. If delta G, delta H, and delta S are all positive, it must be true that T is small. If T were to get too big, that second term would be more negative than the first, and delta G would become negative.
Also, buffers are when there's less of the weak and more of the stronger, whichever one.
It's when you have an, no. It's when you have an equal amount of an acid and its conjugate base, or when you add half as much of a strong acid into a weak base. So you convert exactly half.
Why is it no temperature
Like we have the never option. So what Audrey's telling you is, in this case, we talked about how there is no temperature that will make that reaction spontaneous. So that is the typical question. It's if you know delta H and delta S, at what value of temperature can you make this reaction spontaneous? And the answer to that question is there is no temperature that would make this spontaneous. Because both things are baddies, right? We're sucking energy out of the environment, which is a baddie, and we're making ourselves more ordered, which is a baddie, and so that's never spontaneous. But it's a common answer to that, and why it's on the list, but it doesn't make sense in this question, I would argue. 20. So we're gonna do a method of initial rates in 20. We have the initial concentrations of two reactants, X2 and Y2. And we have the rates. And we're trying to find that rate law. What I'm gonna do is I'm gonna hold one constant, I'm gonna change the other, and I'm gonna look at what happens to the rate, and here the rate does not change. So when you have the concentration and the rate does not change, we're able to say that the rate, which is the rate constant times the concentration of the reactants raised to some powers. I'll call them A and B so there aren't too many X's and Y's here. We know that the order with respect to this must be 0 because changing the concentration did not change the rate. We can hold this one constant and change this. When we double this, the rate quadruples. It goes up by a factor of 2 squared. So this is going to be a 2. So I got that answer, C. (36) What combination of reactants will convert nitrobenzene to phenylamine in 2 steps? First, we need tin and concentrated HCl. You can also use zinc. And second, we need to work that up with sodium hydroxide. That takes the phenylammonium ion and turns it into phenylamine. I don't got anything to say. That's the
just like
answer.
know it.
Yes, that is a know it.
I did not know it.
So I got 35 right, but I don't know how, because I don't know what, it was, I saw retro and I was like, oh, okay, so let me just pick a one, go back.
Yeah.
What is retrosynthesis? I don't know what it is.
Like, what's a retrovirus?
I don't know. I'm old virus.
You guys are all NHL bio. Like,
Retrovirus?
Did we do retroviruses?
I'm not screaming at you. I'm never. So you don't talk about how AIDS is a retrovirus?
No. What does that mean?
We just don't, we did.
Well, it might be on the multiple choice, but like it hasn't been on the multiple choice, I don't think.
All I know is that.
Okay, so I'm gonna finish your answer. So retrosynthesis means starting with your target in mind and working backwards.
Oh, okay.
So I thought that a retrovirus, like, it's gonna go from DNA backwards to RNA or something, like it.
I did like every substance things like before the
So for 21 and 22, we're trying to calculate the activation energy. To find the activation energy, we plot the natural log of K versus 1 over T. In 22, the equilibrium constant is equal to the concentration of the products raised to their coefficients over the reactants raised to theirs. I'm going to plug in the values they gave me at equilibrium, so I'm going to get 2 squared in the numerator. In the denominator, I'm going to have I2 and Cl2 to the third. Ooh. 2 squared divided by 0.2 squared is going to be like 100. Then I would like to multiply this by 2 5s to get rid of it, so it's going to be 2,500. I don't know how to explain the mental math. I don't know how y'all did it.
I just worked straight math. I was just like,
Okay, they just math. I don't like to math.
it's 22.
What? I think it's about writing this down. It's about taking the products, raising it to their coefficients, divided by the reactants raised to theirs. Once we've written this down, I'm plugging in the values they gave me, and I'm just trying to simplify that. Because I would like to change. There you go. Feel like I'm better. The right end. The right end.
It's probably I almost have this question.
Okay, can we move on to paper 2, or is there anything in paper 1 we have not yet answered?
Can you draw methyl ethanolate?
Yes?
I just want to know what it looks like. 'Cause I was like, I
So methyl ethanoate is going to be ethanoate with a methyl on it.
Which one is this?
I have no idea. I was just asked to draw methyl ethanoate, so I did it. Presumably it's number 40. So this would only have 2 peaks in an NMR, and your sample has 3.
Why was question 1 a 20-part
It's
question?
very common.
That was the craziest thing I've ever seen in my life.
It's very, like, that's the expectation. The question 1 will be half the test. Yeah. Absolutely. When we get to August, and it's something has to be way more nervous, right? Okay, we're going back to the multiple choice for a second, 24 and 35. So we answered 24, I think. If you mix together an acid and a base, the equivalence point or neutralization will occur at the same volume of sodium hydroxide. The answer is C. A weak acid has a lower electrical conductivity. A weak acid has higher pH, and a weak acid will give off less moles. But when it comes to the actual amount of the weak acid it takes, it is the same number of moles. Definition of neutralization or endpoint or equivalence is when the moles of acid are equal to the moles of base. And 35 is retrosynthesis. That's when you start with the target molecule and you work backwards. So a DT comes to me and she wants to make an ester. I say that means I need a carboxylic acid and an alcohol. So that is the act of retrosynthesis, knowing your product, and trying to work backwards to think about what reactants would make it, given the reactions you know. So the answer is going to be B, as in boy. Okay, paper 2, any questions, thoughts, complaints? I have questions, thoughts. Don't worry. Mohab, what you got?
6B.
6B?
Yeah.
So in 6B, we want to know if you only get one product, one stereoisomer, how do you know if it's SN1 or SN2? So you can say SN1 always makes a racemic mixture, or you can say SN2 leads to inversion around the stereo center.
Is that because, like, with SN2, you know how it's like a stereo selective where like you're going to go
Yes.
behind?
Yes, the backside attack is referred to as inversion.
So
It's called Walden
can't-
inversion.
I can't just say stereo selective. I
No,
have to say
like the mark scheme said inversion. By the time I realized y'all had the mark scheme, I decided I would use it too. I didn't have it for day 1. Do you really want me to do all of one? Okay, 1C4, and what do you want?
1D3.
1C3 and 1D3. Which one? Probably
What?
3/4 of the class, right?
Oh, no, I don't know what's being done.
Wait, 1C
I'm sitting to you, just
Yeah.
answer any question.
Oh.
No, that's not the answer. 1CII is what's the pH of the solution.
That's D. That's DII.
No. 1C, oh, I'm looking at 1D3.
That's
this is so
D3.
complicated.
That's DII.
So let's do it.
No, I didn't get that. I got like 1.3.
How did you do that?
Okay, Karthika, how clever are you feeling right now?
Oh, none of us got it.
Oh.
Okay, you have 20 cubic centimeters of 0.2 molar. It's on page 3 at the top is the problem I was asked to do.
The one thing that I was
We want to know the pH and we want to know it's at 2 decimal points. Is that fair? Okay, so if you're feeling clever, I'm going to use a green pen that may or may not work. And you're going to say to yourself, I know what happens is that the NH4 plus reacts with the OH minus. Oh, y'all sucked at this. To make the conjugate base in water. Poorly answered question. Poorly. No one knew what they were making, but everyone knew how to solve it. It's full of mysteries, Audrey. So what I believe is that if you have equal amounts of these two things, 100% of them will turn into that. Yes, that is the right answer for that. I don't know what that is, but yes.
It's because of this.
So that is the correct answer for C2.
Yeah. You need that and that.
Wait, that's the correct answer for
Like if you want the spectator ions in there, you can throw them in if that makes you feel better.
But
Well, no, I got it wrong. Because I put one spectator ion and I didn't put the other.
if I didn't put any spectator, never mind. Wait, so are the spectator ions needed for the?
I didn't think so. I don't know. I didn't have the mark scheme at that point, so I was still marking with love. I started marking with hate later.
The answer is no, they're not needed.
Great, thanks.
Oh, yeah.
You're welcome.
She is good.
Wait.
What?
I wrote that,
Oh,
but
I
I
know,
got
I
it
know.
wrong.
It's because I did this. And I did
So unless I like
you put enough.
Like verbally, like, in here. No. Okay, I'll give you a point. Thank you.
Yeah, like I needed both. Like she did it back.
I think I thought you probably needed spectator ions. I wrote spectator ions on my paper.
1 point means a lot.
We'll see if I remark it. We'll see what I wrote on my answer key. Okay, so the spirit of this was not to go to C2, but the spirit of this was to say that if you neutralize a weak acid, what you make is its conjugate base. So I know from the data booklet that Kb for ammonia is 4.75. And so this is the part where I don't know how clever you want to feel. To me, the volume of this solution is doubling. The moles of NH3 will be equal to that. And so the concentration of NH3 will be equal to 0.1 moles per decimeter cubed. So I wrote that down like I knew it. If you didn't feel like you knew it, you could say that the moles of NH4NO3 are equal to 0.2 moles per decimeter cubed times 0.020 decimeters cubed, which is 0.004 moles. And so the concentration of ammonia at the end would be equal to that number of moles divided by that volume. So I wrote the point one like they asked this question a lot. Remember, in titrations on paper 2, there are only 3 points where they will ask you to solve the problem. The 3 points are initially at the half equivalence point, which they asked about in the picture coming next, and here at the end point. And so this whole divide by 2 thing happens enough that I just was expecting it. We still good? Now I claim that what you have in solution is ammonia. It's going to hydrolyze in water to make hydroxide. The pH of the concentration of this is 0.1. Some of it will react. And so KB will be 10 to the minus 4.75, but it will also be equal to x squared over 0.1 minus x. We assume that x is small, so we find that x squared is equal to 10 to the minus 5.75, or x is equal to 10 to the minus 2.875. X is the concentration of hydroxide. So if I took minus the log of x, that would be the POH. That would be equal to 2.875. So the pH will be equal to 14 minus 2.875, which is 11.125, which is 11.13. Yes?
I have a question for the sketch with the user. I have the equivalent point, and like why, so the 9.25, why is it
Because that's the half equivalence point. At the half equivalence point, the pH is equal to the pKa. Since we had looked up the pKb, we knew that the pKa was 14 minus that.
I have the right numbers for the pH question.
So that's how I solved it. If you look at the mark scheme, you're going to see that they don't belabor this whole calling it small. Like they just solve it like you know that x is the square root of k times the initial concentration. I do not know that. I mean, I can prove that formula, but I don't know it. I solve all of these problems right away. No, so Brecken's looking at the crazy organic ones. Yeah, I had pity and I deleted what I presumed to be the hard part, but now I regret it. And he wants to know what the IHD was. I'd like to know where the problem is. I didn't staple my key and it is currently not in any order, so I'm using options. So how did you guys approach IHDing this?
I tried to count the carbons, but I had figured out that I cannot count the carbons. So I don't know. So I just, yeah, so I was just like,
So he just took the paper one after we did listing and paper 2. That's what he said himself, not Josh.
We have 2 ways to do this. Way number 1 to do this is to go ahead and say these rings are cute. Electrons are delocalized, but what I'm gonna do is actually draw them in. If I draw in those double bonds, I have 1, 2, 3, 4, 5 double bonds, 2 rings. The IHD is 7. I don't know, Margaret. I'm just gonna look at you and pretend things are good. Okay, so that's one approach, to count the double bonds in the rings and just to write down the answer. The other approach is to try to figure out what's in this molecule. And so if you're gonna do that, you're gonna start here. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 carbons. There are 1, 2, 3, 4, 5, 6, 7, 10, 12, 14, 16, 17, 18, 19, 20, 23, 26. I missed one. 1, 2, 3, 4, 5, 6, 7, 10. Oh, we're good. No, we're not. Yeah, we're good. We're good. We're good. Sorry, 26. I'm looking at Yasha's.
Making them.
Whatever.
Making them.
The next thing I'm going to do is count the nitrogens. There are 3, and finally I'm going to count the chlorines. There is 1. Now, I am not really good at that formula, and so what I used to do was take a hydrogen take a halogen and turn it into a hydrogen, and take a nitrogen and turn it into a carbon and a hydrogen. So that was my shortcut to not having to memorize a formula. So I'm at C21H30, and now I'm going to use the formula. I'm going to take 21 times 2 minus 2. That's 2N plus 2, 2N plus 2 minus 30, all over 2. 42, 46, 30, I didn't get it right.
It says section 1, section 2.
That's when you let Jesus take the wheel? Really?
What?
Try again. Look at my answers. Page 10, you say? Does anyone see what I miscounted?
What question?
I have 18, one of those, 1, 2, 3. So for butane, I take 2 times 4 plus 2 minus 10 over 2. That's right. Oh, shit. Do we all agree that there are 18 carbons?
Well, I think it's 5. But it's 3 times.
My hydrogens are not right. So there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. They are right. 26.
Wait, is there a double bond
I got 26 again.
But the nitrogen on that thing. The nitrogen is the green.
Got 1.87.
27.
No, it's not what I got.
Where?
I've counted, I got 27. I think that's what I got last time, so I'm not really
I
happy
think
about it.
it's 3 times 10 to the 15. 1.87, right? Minus 10 to the whatever. Right?
Some of you did this way. What is it? 26?
Like at the end, my formula.
26, and then every nitrogen is a carbon and a hydrogen. I believe in that. 30, 21. So where's my mistake? I think I just don't math good. Let's try it again. 21 times 2
42.
plus 2.
Oh, yeah, we just did math it.
added wrong, that thing was wrong. Right, you just need the other ring. That's your ring. I don't know. Ooh, that's terrible. I thought I could count to 7, but apparently I can't. I clearly did it with the rings and bonds. That's what I scribbled. I didn't count. So my hard question for you while Brecken loads up his hard questions for me. Oh, bummer. Bye. I want to know the electrolysis of nitric acid, of ammonium nitrate.